The diagram below shows a potentiometer setup. On touching the jockey near to the end X of the potentiometer wire, the galvanometer pointer deflects to left. On touching the jockey near to end Y of the potentiometer, the galvanometer pointer deflects to left but by larger amount. Identify the fault in the given circuit using appropriate equation. So we have this circuit and this cell is called driving cell. So we must have this, okay? And let us consider this, okay? Galvanometer. We find 0 at the center of the scale. So what we find, on touching jockey near to the end X of the potentiometer wire, the galvanometer pointer deflect to left. So we find this. This is the pointer. So deflection towards left when jockey is near end X. So I'm writing in this way, okay? Next, on touching the jockey near to end Y, the potential of the potentiometer, the galvanometer pointer deflect to left but by larger amount. Next, the deflection is large and to left. So we find deflection is left and is large when jockey is near end Y. So it means that there is some fault in the given circuit because the deflection is one side. So I'm writing over here, the deflection is one side. Therefore, there is fault in the given, okay? Therefore, there is fault in the given circuit. Now, we need to understand why this fault occurs, okay, with the suitable or appropriate equation. Now, when there is no fault, so I'm drawing over here, okay, when there is no fault, then we must have this, okay, EMF E must be greater than EMF E1, 1. Next, on keeping jockey, okay, near end X, if the deflection is towards, let's say, left, then on keeping jockey near end Y, so when we move jockey from X to Y, okay, then the deflection must be opposite, that is towards right. So when there is no fault, okay, then we find the deflection of galvanometer is opposite on keeping jockey near end X and end Y. And if the deflection is towards right, okay, when the jockey is near end X or is at X, then on touching jockey near end Y, the deflection must be towards left. So when we have no fault in the circuit, we must have these condition or cases. Now, Let us come to the question, okay? Now, as I said earlier, the fault occurs when E is less than E1. Next, I'm redrawing the given circuit over here, okay? This length is L, and we have cell having EMF E1. Next, when the negative terminal, okay, because we find the positive terminal, okay, we find the positive, this, we find the positive terminal of E. This is connected to end X. It is given in the question, okay? So when negative terminal of cell having EMF E1 is connected, okay, is connected to end X. So we find this. So in order to eliminate, so I'm writing over here. So I'm writing over here to eliminate the fault EMF E must be greater than E1. Next, the positive terminal of cell having EMF E and the positive terminal of cell having EMF E1 must be connected to one point, that is in this question X. So we have this, that is positive terminal of all the cell must be connected to one point, that is one end of the potentiometer wire. So we have this case, okay? Now we need to explain the fault using appropriate equation. So as I said earlier, the fault occurs when we have this and when we have this. Let us find an appropriate equation for the fault, okay? So for that, let us consider this loop, okay? I'm taking this loop. I'm taking this loop. So I'm drawing over here. Okay, let me draw over here. This is X, this is J, and the length is L. And we find X is connected to positive of E, that is cell having EMF E. So this is positive and this is negative. Let me write in this way, okay, in very short. Positive, so we have this, and this point or this side of the galvanometer is positive and this side of the galvanometer is negative. So we have this. Now to find the appropriate equation, okay, we consider this loop and we apply, okay, we apply Kirchhoff's voltage law, that is sum over V equals 0, okay, for closed loop or closed path. Now let us move in anti-clockwise direction. Then from Kirchhoff's law, okay, what we get? We are moving from negative to positive, okay, that is from low potential to high potential. So EMF E1 is taken positive, and for galvanometer, okay, let us tell the voltage across the galvanometer is Vg, okay. So what do you find? What do you find? We are moving from positive to negative of the galvanometer. That is, we are moving from positive terminal or positive side towards the negative side. That is, we are moving from high to low, high potential to low potential. For that reason, Vg is negative. Now, we are moving from J to X. Clear? So we are moving from negative, that is low potential, to X, that is high potential. So I'm writing in this way, E Xj, okay. This whole equals 0. And what is E Xj? So this is drop in potential across the length Xj. And from the principle of potentiometer, okay, drop in potential, that is E Xj equals K times length. So this is from principle. This is from principle of potentiometer, okay. Now we can write in this way, okay. Vg equals E1 plus EXJ, and EXJ is K times L. Now we use this equation, okay, to explain why we are getting one side deflection, and when we put jockey near end X, okay, we get smaller deflection towards left side, and when we put jockey near end Y, we get larger deflection, okay, towards left. Now what we find, okay, from this equation, so this is the required equation I'm writing, okay, this is the required equation. So we have this. Now when Vg is small, that is deflection is small, okay. So when we have small deflection, then Vg is small. This happens when L is small, that is when we put jockey near, okay, end X, that is when we put jockey near end X. So we have this, okay. So we can understand it in this way. This is Y, this is X when we put jockey near end X. then the length is small, okay? So when the length is small, then the deflection is small. Next, now when Vg is large, that is deflection is large. So this happens when L is large. When L is large, then Vg is large, mean that deflection is large. That is when we put jockey near end Y. That is when we put jockey. So let me draw in this way, okay? When we put jockey near end Y, clear? Then the length, okay, is large. L is large, then the deflection is large. And when we put jockey near end X, then the length L is small, due to which the deflection is small.